Welcome to aminacademy.com. In fluid mechanics, let us discuss about the momentum equation and moment of momentum equation. First, let us discuss about the momentum equation. It is based on the law of conservation of momentum or on the momentum principle, which states that the net force acting on a fluid mass is equal to the change in momentum of flow per unit time in the direction. The force acting on the fluid mass m is given by the Newton's second law of motion. Let the force on a fluid mass let the force on a fluid mass m is given by Newton's second law of motion. That is F equal ma, where m equal mass of fluid element and a is acceleration, where m equal to mass and a equal acceleration. F is force exerted. We know that a equal dv by dt. Change of velocity with respect to time is a. Therefore, we can say F equal to ma m into dv by dt. F equal m is a constant, so we can put it inside the derivative also. That is, we can get it m then d of mv by dt. Then here this is m dv by dt. Then by cross multiplying, f dt equal d of mv, which is known as impulse momentum equation, which is known as impulse momentum equation. Momentum equation where force F is acting on a fluid of mass m, a short interval of time dt is equal to the change of momentum. Here where d of mv equal change of momentum that is force acting with change of momentum, and f dt equal to impulse, means force acted on a body very short time is called impulse. Therefore, impulse equal to change of momentum. Next, we will discuss momentum of momentum. Momentum of momentum principle. Moment of momentum Moment of momentum equation is derived from the momentum of momentum principle, which states that resulting torque acting on a rotating fluid is equal to the rate of change of moment of momentum. Here, the moment of momentum principle is the resulting torque acting on a rotating fluid. Rotating fluid is equal to the rate of change of momentum of momentum. Moment of momentum. Moment of momentum. This is the principle. Now let V1 velocity of a fluid at section 1 in pipe or channel in pipe, and R1 radius of curvature radius of curvature where the fluid is rotating at section 1, Q rate of flow fluid, rate of flow of fluid, rho density of fluid, and V2 R2 equal velocity and radius of curvature of at section 2. Section 2. Momentum of fluid. Now we can say momentum fluid at section 1 is equal mass into velocity. Mass into velocity, that is rho Q, density into volume per second, rho into Q, mass into velocity. Velocity is V1 per second, and momentum of fluid at section 2 is same rho Q into V2 per second, which is equal rho Q from that moment of momentum. For the first we'll do moment of momentum, that is second momentum. Moment of momentum at section 1 is rho q v1 into radius of curvature r1. Same moment of momentum at section 2 is rho q v2 r2. Therefore, rate of change of momentum. This also per second. Here, rate of change of momentum. Therefore, rate of change of momentum is final momentum minus initial moment of momentum. That is rho q v2 r2 minus rho q v1 r1. Common, rho q is common, v2 minus v1, v2 r2 minus v1 r1. Therefore, according to momentum of momentum principle, by moment of momentum principle, is resulting torque equal change of moment of momentum. Change of moment of momentum. Therefore, resulting torque T, let it is T equal rho q v2 r2 minus v1 r1. This called moment of momentum equation. Note the point here. For this moment of momentum equation is useful for analyzing flow problem in turbine and centrifugal pumps. In turbine and this principle of result is used to solve the problem in turbine and centrifugal pump. For finding the torque, also it's useful. For finding the torque, for the torque exerted in water, exerted by water sprinkler. Water sprinkler, etc. So these are useful things we have done. Please subscribe our YouTube channel.